up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA Network Plus 009 certification. So let's get into it. Physical network installations are fundamental to establishing reliable and scalable infrastructure. So whether setting up a small or large enterprise network, key considerations such as equipment locations, rack sizes, power management, cabling, and environmental controls play a crucial role in performance and longevity. And in this video, we're going to go over the CompTIA Network Plus exam objective 2.4, focusing on essential factors that impact physical installations. All right, so let's begin by talking about some important installation implications. And we're going to talk about IDFs and MDFs, or intermediate distribution frames, and main distribution frames. Networking infrastructure is typically organized into two main physical locations: the intermediate distribution frame and the main distribution frame. And understanding their roles, this ensures efficient data transmission and structured cable management. So let's talk about the MDF. So this is the primary hub of network connectivity within a building or facility. It connects external circuits such as internet service providers to the internal network, and all network traffic is routed through this centralized point, making it critical for stability and performance. And the MDF is also located in a secure area with proper ventilation. It houses core network components like routers, switches, and patch panels, and it must be easily accessible to IT professionals for maintenance and upgrades. Then we have the IDF, and the IDF serves as a secondary distribution point within larger buildings or campuses, typically located on different floors or wings. And the IDF is connected to the MDF via backbone cabling, which is often fiber optics for high-speed data transmission. It also facilitates shorter cable runs to workstations, reducing latency and clutter, and it requires environmental controls that are similar to the MDF. All right, next let's talk about rack size considerations. So rack mounted equipment, this is standard in structured networking environments, and the size and configuration of a rack, this directly impacts space utilization, cooling, and accessibility. So we have what are called rack units. So equipment racks, they are measured in standard units represented by the letter U, where 1 U equals 1.75 inches of vertical space. And the common sizes are 42 U and 48 U for data centers, and 24 U and 12 U for smaller installations. And this ensures compatibility with standard networking gear such as switches, servers, and patch panels. Then we have depth and width. The standard rack depth is 19 inches, and this is common for networking and server equipment. And deep racks, which could be 29 to 42 inches, they accommodate cable management and airflow optimization. And then you have width considerations, and these are 23-inch racks, and they are less common, but they exist for telecom equipment. All right, next we have what is called port side exhaust, or intake for proper airflow. So proper airflow management, this is critical to prevent overheating and ensure network reliability. So front to back cooling, this is preferred in most data centers. Side to side airflow, this may be necessary for certain switches and network appliances. And this ensures adequate spacing between equipment and uses blanking panels to direct airflow efficiently. And then there's also the implementation of hot aisle and cold aisle arrangements in large scale installations. All right, next we have cabling considerations. So structured cabling is essential for an organized and efficient network. This minimizes interference, simplifies troubleshooting, and improves scalability. So we have patch panels, and these allow for easy cable management and organization, reducing stress on network ports. So you want to make sure you're labeling the ports to enhance troubleshooting, and this helps in future expansion and maintenance. You have fiber distribution panels, and these are essential for fiber optic connections, and they protect delicate fiber optic strands, and they also provide an organized way to connect backbone infrastructure. Then you have lockable enclosures, and these are network cabinets and patch panels that should be lockable to enhance security to prevent unauthorized access. And ultimately what they do is restrict physical tampering with critical connections, and they also ensure compliance with security policies in regulated industries. All right, so let's move on and talk about some power considerations. So reliable power solutions are essential for network availability, and proper planning prevents downtime and protects equipment from electrical issues. So let's talk about the UPS, or the uninterruptible power supply. So in UPS, this provides temporary backup power in case of electrical outages, allowing for graceful shutdowns or continued operation. And the first type of UPS you have is called an online UPS, and this provides continuous power with zero transfer transfer time, which is ideal for mission critical environments. Next, you have what is called a line interactive ups, and this adjusts voltage fluctuations without using battery power, and this is common in offices and small server rooms. And then you have what is called a standby ups, and this switches to battery power during an outage, and this is suitable for non-critical devices. All right, next we have what is called a power distribution unit, or a PDU. And a PDU, they distribute electrical power to networking equipment in racks. And you have what is called the basic PDU, and this is your standard power strip for distributing AC power. And you have what is called a metered PDU, and this displays power consumption for monitoring. And then you have what is called a switched PDU, and this allows remote power management and rebooting of devices. Next, we have power load and voltage considerations. So understanding power loads and voltage requirements, this ensures equipment runs efficiently without risk of overload or failure. So you want to calculate power consumption, and this is the total wattage of connected devices that must not exceed the PDU or circuit capacity. Then you have various voltage options. So you have 120 volts, and this is standard in North America for most office equipment. Then you have 208 volts all the way to 240 volts, and this is common in data centers for increased efficiency. Do you have redundant power supplies that can mitigate single points of failure? All right, so let's move on and talk about some environmental factors. So proper environmental management, this extends the life of networking equipment and ensures stable operations. So let's first talk about humidity control. So humidity levels, they should be controlled to prevent corrosion and static electricity buildup. And the ideal humidity range should be about 40 to 60%. Now, if it's too high, this can cause condensation, which can lead to short circuits. If it's too low, this can increase static electricity, which can damage components. And so you also want to use humidifiers and dehumidifiers that are based on climate conditions. Next, we have fire suppression systems. So networking equipment, this is vulnerable to fire hazards due to high power consumption and heat generation. So gas-based suppression systems like FM200, CO2, or Novec 1230, this can prevent damage to sensitive electronics. You have water-based systems that should only be used as a last resort. Then fire suppression, this should be integrated with smoke detection and alarm systems. Next, there's temperature control. So maintaining optimal temperatures, this prevents equipment failure and ensures network stability. And the ideal range is 64 to 80 degrees Fahrenheit, or 18 to 27 degrees Celsius. You have some cooling methods like HVAC systems, and these are your standard air conditioning units for server rooms. You also have what is called a CRAC unit, or a computer room air conditioning, and this is specialized cooling for data centers. And then you also have liquid cooling, and this is used in high performance computing environments. All right, so in conclusion, successful physical network installations, this requires careful planning and adherence to industry best practices. And key considerations include strategic equipment placement of the MDF and IDF, proper rack configuration, structured cabling, reliable power sources, and environmental control. And by implementing these principles, network professionals, they can create efficient, secure, and scalable infrastructures that align with the CompTIA Network Plus standards. Now, with all of that being said, let's do some check on learning. So which of the following is the primary purpose of an intermediate distribution frame in a structured cabling system? Is it acts as the central point for all network connections in a facility? Is it provides backup power to networking equipment? Is it is used for fire suppression and environmental monitoring? Or is it connects end user devices to the main distribution frame? And the correct answer is it connects end user devices to the MDF. So the IDF, this is a secondary distribution point that connects to the MDF, allowing network connections to be extended to various floors or areas in a building. And the MDF, this is the primary hub where external network connections enter the facility. Next question, which power-related factors should be considered to prevent damage to network equipment due to power fluctuations? Would this be port side exhaust configuration? Would this be an uninterruptible power supply? Would this be a fiber distribution panel? Or would this be the rack size? And the correct answer is this will be an uninterruptible power supply. So an UPS is critical in preventing sudden power losses or fluctuations from damaging network infrastructure. It provides backup power in case of an outage, allowing devices to safely shut down or continue operating until power is restored. And our final question, which of the following environmental factors is crucial to monitor in a network equipment room to prevent overheating and equipment failure? Would this be proper humidity levels, lockable racks, patch panels, or power distribution units? And of course, the answer is going to be proper humidity levels. So, maintaining appropriate humidity levels, this is essential in data centers and network rooms. Low humidity, this can lead to electrostatic discharge, also known as static electricity, while high humidity, this can cause moisture buildup, leading to short circuits and corrosion. So, temperature control, this is also important to prevent overheating of network devices.